Hello, I'm Lena Taro. Let's take a look at how we can use Fathom and simulation to answer the following question. About 7% of men in the United States have some form of red-green color blindness. Suppose we randomly select one U.S. adult male at a time until we find one who is red-green colorblind. How many men would we expect to choose on average? To begin, I created a collection called Colorblind, and in this collection I have a variable called blind, and I have 7 yeses to represent the 7% of men who are colorblind, and the remaining 93 cases are no's. Let's begin by randomly selecting from this collection. We'll sample cases, and we've selected 10 cases. I don't want to select 10 cases. It might take 10 or it might take more until we find a man who is red-green colorblind. So I'm going to select until condition, and I'm going to select until we see blind equaling a yes. And I'm going to turn the animation off, and we'll replace the existing cases. And we're going to do this with replacement. And what that means is that I don't want to pull out a Y and then an N and then a Y and leave those out. I want to make sure the 7% stays the same from trial to trial, or from selecting a man to selecting another man, and so on. Let's pull this open a little bit more, and we'll say sample more cases. So let's take a look. Here it took us 15 tries until we found a man with red-green colorblindness. We'll do this again. This time it only took 3 tries. So what we want to do is we want to count how many times it takes until we find that man with red-green colorblindness. So we need to create a measure, and I'm going to call that measure count. And I want to count how many times I had to pull until I found a man with red-green colorblindness. So that was 3. That matched what we saw here. Let's just make sure that this measure does actually calculate or measure what it's supposed to measure. We'll say sample more cases. We can see this time it took 21, so when I click over here for count, I should see 21, and I do. So now we need to collect some measures. So I right click here and I say collect measures, and we can see that we've collected 5 measures. Let's pull a graph down here and look at our counts. So one time we found the red-green colorblind person on the 2nd try. Another time it took us 5 tries, 7 tries, 8 tries, and this time we found 8 men that did not have colorblindness, and on the 9th man we found a man with red-green colorblindness. So now we need to actually collect some more measures. 5 is not enough for us to see the pattern. So let's collect some more measures. And let's turn the animation off, and let's collect 95 more measures. So we'll have a total of 100 measures here. So we can see that sometimes it takes quite a few attempts until we find one man with red-green colorblindness. But the answer to the question here is how many men would we expect to choose on average? Let's find the mean for this distribution. To do that, I'm going to right-click and go down here to the bottom and say plot value. I want to plot the mean. So it looks like it might take 17.15 men on average. Let's do this again. Let's inspect the collection here. Let's do another set of 95, or actually another set of 100. I'll replace the existing cases, and we'll see how the mean here changes. So that time it would take 13.34 on average based on this simulation, or maybe 13.2, or 13.37. So there's quite a bit of variability here. Let's just collect 1,000 measures. And we can see that when we collect 1,000 measures, that it takes about 14.33 men on average until we see that one man with red-green colorblindness.